Hello, you're welcome to the math classroom. This lesson is on integration. So our lesson today we are looking at what the Riemann sum is. And this will lead us to the integration we know about. Let's look at this curve. Let's say I have this curve. Okay, so you have a curve. Okay, and you are asked to find the area under this curve. So this is our x. Let's say this is what our y, and we want to find the area under the curve here. So you ask yourself, how do I go about it? Because this doesn't look like the normal polygon shapes we know, which becomes easier. If it's a rectangle, you know how to find the area. If it's a rhombus, it's easy to find as well. But here is the case where you have this curve to find the area. If you remember when we had a rhombus or a parallelogram, when you had something like this, and you asked to find the area or the perimeter, if you remember, we try to partition what we have. So we used to do some partitions. Then we find the area of this, that, and this. Then what do? You add up. So when you have a non-negative function like this, which is continuous over a certain interval, let's say interval, we are saying it's from x0 equal to a to xn, which is equal to b. I can partition this. So my interval is from what? A to b. This is the interval. Okay, so with this interval, we can partition. So we want to partition in such a way that we can find for the defined shape you have. So let's say you partition to the best approximation such that, let's say I have x1. So let's say this is x1, x2, x3, x4, x5, to you have xn. You partition in such a way that you have equal width. Your width should be equal. So we have equal width, which is very important. And the corresponding points, the sample points will correspond to the right end points of the sub-intervals we have. So if I have a non-negative function, so let's say this curve we are looking at, this curve, the function of this curve is y, which is equal to f of x, a function of f of x. And we divide this interval. Okay, so you realize that we divide this into n equal sub intervals. This is the interval, and we are dividing it into equal width. So if I divide into equal width, then we are saying my change in x, the change here is going to be the b, my endpoints from minus my a divided by n. This is the change I have. Then the right points of the intervals. So this is the right end point of the intervals, our x1 to xn to xn. That is going to be our right end point. So sk is going to be my a plus my change k, change in what? X. Don't forget our xn here, it's equal to b. From here, xn, it's equal to b, the last interval you are looking at. So with this, then what happens is I can define a Riemann sum. So the whole objective is you want to construct a rectangular shape. With what? Equal interval, so that we can find the sum of that. So you realize that the base of each rectangle, so if this is a rectangle, the base of each is going to be what? Changing x. And the height of the rectangle here, let's say the height is going to be what? K. The height of the rectangle K is going to be f, the function f of what? Sk. This is the height. So it follows that, for each, you realize that my area is going to be what? My base times the height. And what is the base? My base is what? Change in x. And my height is what? F of what? Sk. This is the area. But we are looking for the sum of all the areas. So the sum of all the areas is area 1, 2, 3, 4, 5, 6, 7, and what? 8. So that if I want to find the sum of all the areas, then the sum of the areas of all n rectangles is going to be what? Is what we called, is called the Riemann sum. And we define the Riemann sum to be, so our definition for Riemann sum is going to be, let's define that. So the definition for Riemann sum is going to be the sum of what? All the rectangles I have. So summation k equal to 1 towards n sub-intervals f of what? Sk, change in x. F of sk, change in what? X. And now we already know what sk is, and you know what your change in x is. So with this definition, this definition will lead us to what we call the definite integral. So in our next lesson, we introduce the definite integral. Don't miss that lecture yet. Till then, kindly stay safe. Bye.